Welcome back to our channel. Today we have a fascinating topic that combines technology and nature, and it's something that's becoming increasingly important in our world. Using augmented reality for pest control. Pest management is crucial for agriculture, urban living, and even our health. But how do we keep pests at bay while minimizing the use of harmful chemicals? That's where AR comes in. First, let's take a look at what augmented reality actually is. AR is a technology that overlays digital information, sounds, images, and text onto the real world. When utilized in pest control, it can provide us with essential data about pest presence and behavior, guide us on effective treatments, and even educate users on handling pests without chemicals. The creators of modern AR technology, like Google and Apple, have laid the groundwork for applications across various sectors, including agriculture and pest control. To understand how this technology can be practically applied, we'll create a simple Java program that simulates a basic AR pest control application. Our app will enable users to identify common pests, display relevant information, and suggest control methods. We'll be using JavaFX for our graphical interface. Let's start by setting up our environment. Make sure you have Java installed on your machine. If you haven't, you can download it from the Oracle website. Next, we will also need to download a JavaFX SDK if you haven't set that up already. You can find this on the official JavaFX website. Once JavaFX is set up, we can create a new project in your favorite IDE like IntelliJ IDEA or Eclipse. Now that our IDE is ready, let's create a new JavaFX application. Start by creating a new Java class called Pest Control AR. This class will extend the application class from JavaFX. Let's write our first piece of code to set up a basic JavaFX window. This code sets up a simple window for our application. We create a stage as the main window and a scene that holds our layout. The stack pane is a simple layout manager that allows us to stack nodes on top of each other. Now we can run this code to see our basic application window. Next, we need to incorporate some elements that will aid in pest identification. We will create a button that, when clicked, will simulate scanning for pests. Let's add a button component to our user interface. Here, we created a button labeled Scan for Pests. We also defined an action handler that will be invoked when the button is clicked. For now, we will leave the logic inside the action handler empty, as we will implement it later. Now, imagine a user clicks the Scan for Pests button. In a real AR application, we would use a device's camera to analyze the environment. However, for this simulation, we will create some mock data representing common pests and their characteristics. Let's create a method that simulates pest detection. This method randomly selects a pest from our predefined array of common pests. In a practical application, this method could interface with AR hardware or even a pest detection API to provide real-time data. Now let's integrate this detect pest method into our button's action handler so that when the button is clicked, it displays the detected pest to the user. When you run the application and click the Scan for Pests button, you should see the detected pest printed in the console. This is the core function of our AR pest control application, simulating the scanning process. Next, we want to provide users with information on how to manage the detected pests. To accomplish this, we can create a method that returns a control suggestion based on the detected pest. This getControl method takes the detected pest as input and returns advice for managing that pest. This educates users on the appropriate, eco-friendly actions they can take to control pest populations without harmful chemicals. We will now update the button's action handler to make use of the getControl method. When the pest is detected, it will also print the appropriate control advice to the console. Now, when you run the program and click Scan for Pests, you will see not only which pest was detected, but also how to deal with it responsibly. This is the power of bringing technology into pest control. As a next step, let's think about how we can enhance this application to make it more intuitive and user-friendly. One way is by displaying information visually instead of just printing it in the console. We can dynamically update the contents of our JavaFX application to show the detected pest and management advice on the UI itself. In this updated example, we added two label components to our layout, one for displaying the detected pest and another for showing the control advice. After detecting the pest, we now set the text of these labels based on the results. This gives users a clearer and more immediate understanding of the pest control process. It's also desirable to enhance user experience further by providing engaging graphics or images. For instance, we could add a picture of the detected pest alongside the relevant information. You'll need to have images of the pest saved in your resources folder. Let's change our program to show images as well. In this updated code, we created an image view component that will display images of the pests. The getPestImage method returns the image associated with the detected pest. The pest picture will now be shown on the UI when detected, enhancing the user experience by providing visual feedback. Finally, let's add a bit of polish to our user interface by applying some CSS styling to our JavaFX application. This can differentiate our application and make it more visually appealing. Let's create a CSS file for our application. Here, we added a reference to a CSS file named style.css. You can create this file in the resources folder. You might want to style your labels and buttons, giving them colors, fonts, and effects to enhance your app's appearance. Here's an example of what you can include in your CSS file. In this CSS, we style the labels to be green with a larger font size, and our button is given a light blue background with rounded edges. The image view also has specific sizing applied. This will elevate the overall user experience of our application. You've done an amazing job following along. By the end of this tutorial, you now have a basic AR pest control app that helps with pest identification and provides environmentally responsible solutions. We've learned how to create a JavaFX application, handle UI components, and even style components with CSS, which will set you up for more advanced AR applications. If you enjoyed this tutorial, please give us a thumbs up and consider subscribing for more insightful videos on technology and programming. If you have any questions or suggestions for future tutorials, leave them in the comments below. Until next time, keep coding and enjoy the blend of technology with nature.